After the following lecture, students will be able to identify both the oxidizing and reducing agents in a chemical redox reaction, and students will be able to write half reactions for the oxidizing and reducing steps of said redox process. Redox reaction balancing is directly connected to normal balancing in the sense that the conservation of mass has to be maintained. The difference with redox reactions, though, is that there has to also be the conservation of electrons, meaning that electrons that are given away by one reactant have to be picked up by another reactant. Another set of definitions that we are going to encounter in this lecture are oxidizing agent and reducing agent. These are a different way to look at reactants in a redox process. So the oxidizing agent is the substance that's going to cause something else to be oxidized. So oxidizing agents do the oxidation. Okay, and since they cause other things to be oxidized, that means they have to be the thing that's being reduced. So oxidizing agents will accept electrons and get reduced. Reducing agents, on the other hand, is the substance that's going to cause one of the other reactants to be reduced. So in that context, if they are causing something else to be reduced, they themselves are being oxidized. So they are going to be giving away electrons or getting oxidized. Okay, so these two definitions can sometimes be somewhat confusing for some students. So make sure that you sit down with these concepts and differentiate them between oxidation and reduction, those processes and what they mean, and then apply the identification of oxidizing agent and reducing agent. So when we go ahead and write half reactions, the process of writing half reaction basically takes us into the realm of applying some of the things we've already learned. So the first thing that we're going to do is we're going to basically look at our oxidation numbers to help us identify what substance is being oxidized and what substance is being reduced. Okay, so if we go ahead and look at this first SN here, it has a +2 oxidation number. Okay, so on the right-hand side, it has a +4 oxidation number. So when we go from +2 to +4, we know that we have lost 2 electrons. Okay, so we have been oxidized. So that's our oxidation step. Okay, we're going to do that same process with the other reactant. So in the case of iron +3, we know its oxidation number is going to be +3. On the right-hand side of the arrow, it is +2. So we've gone from +3 to +2. So we know that we have gained an electron. Okay, so we have been reduced. So we've identified our oxidation and reduction steps, and this will now allow us to write our half reactions for both the oxidation and reduction processes. Okay, so if we're going to go ahead and start out with the oxidation process, we know that SN2 plus is going to turn into SN4 plus. Okay, and we know that in the oxidation process, SN2 plus is losing 2 electrons. So we know that one of the products that it has produced is those 2 electrons. Okay, now if we look at this for the reduction process, okay, so we know we have Fe3 plus. Okay, it's going to Fe2 plus. Okay, and each one of those Fe3 pluses has gained an electron. Okay, so it's going to be one of the reactants because the electrons have been picked up by the Fe3 plus. Okay, so now this also brings us to identifying our oxidizing and reducing agents. Okay, so we've written these half reactions, okay, for both our oxidation and reduction process. The substance that is getting reduced is going to be your oxidizing agent. Okay, so the substance that is being reduced in this context is my Fe3 plus. So my Fe3 plus is going to be my oxidizing agent. So I'm just going to mark it as OA. Now the substance that is being oxidized is going to be your reducing agent. Okay, so my SN2 plus here is being oxidized, so it is my reducing agent. So these identifications are things that you guys will basically get better and better at as you practice. A few things I want to note about both identifying oxidizing and reducing agents and writing half reactions. First thing I want to note is about the identification of the oxidizing and reducing agent. In these contexts of writing, oxidizing and reducing agent, okay, I want you to understand that I do not want you to pick out just the individual atoms that are being oxidized or reduced. So, for instance, let's say we had something like HCl going to Cl2. Okay, we know that chlorine has an oxidation number of -1. Cl2 is 0. Okay, so we know that we have lost electrons in this context. Okay, so we know that HCl, or the Cl in HCl, has been reduced, okay, to give us that Cl2 molecule, right? So in this context, we know that Cl- has given away electrons in some way. Okay, so in this context, that means that chlorine is providing electrons. So it is acting as an oxidizing agent. Okay, now when you answer the question of what the oxidizing agent is, you're not just going to circle only the chlorine and the HCl. Why? Because they don't exist as separate entities. Okay, so when you identify the oxidizing agent for the process that we're looking at right here, you're going to indicate that HCl is your oxidizing agent. Why? Because in order to get this process to happen, I have to add the molecule HCl for the process to occur. Okay, so that's the first point I want to mention. The second point I want to mention is regarding the balancing of the half reactions. Okay, so if I only ask you to write half reactions, okay, this is the format that you're going to use. You're going to balance out the electrons, you're going to put them on the correct side, all of that good stuff. Okay, however, when we actually talk about the complete balancing of redox processes, which we'll discuss in our next lecture series, we're going to only write the simplest form of this half reaction. And in the context of this example that we just did, all we would include are these pieces, okay, right? So the pieces that I've boxed in red, those are the only pieces we will include. And the reason why is not because these are incorrectly written half reactions. The reason why is because the balancing steps that you are going to learn for the redox process balancing for acidic and basic conditions basically has steps that adjust for the number of atoms as well as the number of electrons and all of that good stuff. Okay, so if I'm asking you to write just half reactions, I'm not asking you to balance the equation. You go ahead and do this writing like we discussed at the very beginning of this slides lecture. Okay, if we're talking about overall balancing of the chemical equation, you're going to take the additional steps that the balancing procedures tell you, so you're going to write the more simplified examples that we discussed here.